Hey guys, welcome back to lecture series on Z transform. So for more videos, you can check in my description box as well in I button. You will get the complete lecture series based on the linear differential equation with a constant coefficient, Fourier transform, sine and cosine and their inverse transform. And I uploaded plenty of the videos based on the Z transform. So if you want more videos, check in my description box. Okay, so in my today's video, I'm gonna explain to you all find out the Z transform for Z transform of 3 raised to k by k factorial. I want the Z transform for this function. Okay, so you can directly solve this one by using the definition for Z transform. Okay, which is summation minus infinity to plus infinity. Okay, and a z raised to minus k. Okay, f of k z raised to minus k. You can apply that definition. It can be useful for solving. But if you want to time saving strategy, so you can apply some of my results that I already proved in my previous lecture. Okay. Yes, so what is the result that we know, standard result for a Z transform? Okay, so we know that the one result, let me write that result here, so it will be easy to solve the example. Okay, so let me write this one. I already explained in my previous lecture, guys. Okay, so if you want, you can check it in my playlist. So we can write f of k. Okay, if we have sequence f of k is a raised to k by k factorial. Okay, so see that similar sequence it look like here. Okay, so we write it's a Z transform. We write it's a Z transform. We write it's Z transform. Okay, so how can we write the Z transform? We write it's a Z transform as a e raised to power a by z. Okay, I explain how that it is coming. Okay, e raised to a by z, how it is coming. Z is complex number. We write a plus ib. Okay, so I explained this one in my previous lecture. We just have to apply directly the standard form. Okay, so you can apply standard form or you can apply the definition. It is completely up to you. Okay, yes, let me solve this one further. Okay, so what we have, f of k is equal to a raised to k by k factorial. Now see that Z transform of 3 raised to k by k factorial. So what is the value for a? We need the value for a only. Okay, so value for a, it represent value for a which is a 3. Okay, I hope you all have understood why a is 3. Okay, a raised to k means 3 raised to k. So value for a it is a 3. Okay, so Z transform of under curly braces 3 raised to k by k factorial can be written as, okay, a raised to k by k factorial can be written as a raised to a by z. Okay, a raised to 3 divided by z. This one is our required Z transform. See guys, it is the solution in only one step. It is only one step solution. You will get 2 to 3 marks for such steps. Don't have anything difficult, very easy solution. Okay, just need to remember this form. Okay, whenever we have a raised to k by k factorial, we write it's a Z transform a raised to a by z here. Okay, yes, this one is our required form. Z of 3 raised to k by k factorial is a raised to 3 by z. Okay, this one is our required Z transform. Okay, let's go for some more examples. I want to take 2 to 3 more examples so that we conclude here our today's session. Okay, yes. So here I consider one more example, Z transform of 2 raised to k plus 1/2 2 raised to k and k greater equal 0. Okay, so here we are going to apply Z transform of a raised to k. Okay, so already you all have learned Z transform of a raised to k in my last lecture. So we write Z transform of a raised to k whenever k greater equal 0. There is a Z transform for k less than 0 also, but we don't want that less than 0, we want the greater than 0. Okay, so Z transform of a raised to k whenever k greater equal 0. Okay, we write it's a Z transform as a Z upon Z minus a. Okay, Z upon Z minus a, and we have condition modulus of Z greater than modulus of a. Okay, this one is the condition we have here. Okay, for Z transform. Okay, let's apply Z transform for our sequence. Okay, by linearity property we can separate this one. Okay, so by linearity property, by applying linearity property, I'm going to write Z transform of 2 raised to k plus 1/2 2 raised to k as Z transform of, we write it's a Z transform of 2 raised to k when k greater equal 0 plus Z transform of 1/2. Okay, Z transform of 1/2 raised to k. Okay, and k greater equal 0. Now see that I have two Z transforms separated over here. Okay, so need to apply Z transform of A raised to K. So for this condition we have A which is equal to 2, and for this condition we have A which is equal to 1/2. Okay, so replace A is a 2 and A is 1/2 and add up them together, so you will get the complete Z transform for this sequence. Okay, yes, so let me write the Z transform. Okay, Z transform of 2 raised to K. So what is the value for A here? 2. And what is the value for this one? Gives us the value A 2, and this one gives us the value A, which is a 1/2. Okay, yes. So replace A and 2 and 1/2 here in this Z transform. So we write next step as a Z upon Z minus 2 plus Z upon Z minus 1/2. Okay. So this one is our required answer, guys. We don't have anything later. This is need to find out the just to need to find out the Z transform of 2 raised to K plus 1/2 raised to K, which gives us the value Z upon Z minus 2, Z upon Z minus 1/2. Okay, don't have anything. Okay, so we go for some more examples. Okay, so you can take some example for your homework also, and we practice some example more here. Okay, let me write one example. So here I taken one more example, Z of E raised to alpha K when K greater than 0. We have to find out the Z transform for this exponential sequence. Okay, yes. Now see that we are going to apply E. What is mean by E? What is mean by E? We know that E can be written as 2.78 something. This is the constant value for E. Okay, and this A also represent the constant value. That means we consider A which is equal to E and which is equal to 2.78. Now we can see that A raised to alpha K. Similarly, I got this form again. Okay, Z A raised to K and K greater equals 0. So we write Z upon Z minus A mod Z greater mod A. Okay, yes. So mod A means, now we have mod A means A raised to alpha. Okay, this one is alpha. Okay, now let me write first of all, what is the value for A. Okay, so we want the A raised to K. Now A raised to K, that means we write E raised to alpha raised to K. Okay, so Z transform of E raised to alpha raised to K. Okay, so whenever power to the power we can multiply them. So we consider E raised to alpha raised to K. Okay, and now see that E raised to alpha it is constant here, E it is also constant. This entire term gives us the constant. Okay, that means we consider A which is equal to E raised to alpha. What we consider here, A which is equal to E raised to alpha here. Okay, yes. So I got the value for A. It's not difficult, it's way easier. We need to compare this form, this entire form with our given example. Okay, yes. So I got the value for A which is equal to E raised to alpha. So I'm going to write it's a Z transform upon Z minus A, and A which is equal to E raised to alpha. Okay, and we have condition mod Z greater than mod A. So mod A means mod E raised to alpha. Okay, that one is our required answer. Okay, it's not difficult, guys. It's one of the easy solution. So just need to remember 3 to 4 standard forms for finding the Z transform, or you can directly apply definition for Z transform too. You will get the required answer. Okay, so you can refer this my solution for your understanding. Okay, take the note of this one. So let me give some example for your homework over here. Okay, try this example for your homework. So guys, here I consider I given here 2 example. Okay, try this example for your homework. So as we have cos A plus B and sin A plus B expansion. So for your references, I'll tell you all the form here. Sin A plus B can be written as sin A cos B plus cos A sin B, and cos A plus B cos minus sin. Okay, these 2 results apply over here. Expand this trigonometric term, apply linearity property, and find out the Z transform of cos alpha K and sin alpha K. Okay, take the constant term outside. So keep this example for your homework and tell me the answers. Okay, tell me the answers in my comment section. Okay, so that one is here for our today's lecture. Okay, so I hope you all have understood a linearity property for these mini Z transforms. Okay, for your reference you can note it down our today's lectures notes. Okay, so that is here for our today's lecture notes. I hope you all have understood my entire today's lecture, guys. Okay, so that's it here for today's lecture. Okay, in our next lecture we go for the change scale property. Okay, change of scale property, we go for it on for that property in our next lecture. I hope you all have understood here my today's entire lecture, guys. It's not nothing we have difficult here. It's one of the easy lecture. Even after, if you found anything difficult, let me know in my comment section. I will come up with the similar videos. So thank you everyone. Thank you for my today's lecture.